Hi friends, welcome back. Today we are going to solve Leetcode problem 1970 last day where you can still cross. Recently I come across this very interesting problem on Leetcode. This is one of the hard problems, and as you can see this is a very likable problem from like and dislike ratio, and this also test one of the very important, like two of the very important concepts actually. So I found this problem very interesting, and I just thought that it's worthwhile to create a video so that you guys can understand how to solve this problem. So I can discuss the logic and approach we can use to solve these kind of problems. So today we will do that. But before we start looking into the problem details, I want to mention that my channel is dedicated to help people in their Java J2E and coding interviews. You will find more than 400 different varieties of coding questions on my channel, which are solved and explained using whiteboarding session, examples and Java code. Those questions are taken from previously asked coding interviews by Google, Facebook, Microsoft, Yahoo, Amazon, Apple, and many other big financial companies. So if you are preparing for any Java J2E interviews or coding interviews, then this channel can definitely help you in your interview preparation, because there are lots of vast varieties of problems as well as Java J2E related videos that you can use for your preparation. So please subscribe to this channel now. So let's start with the first. We will just go quickly through the problem statement, then we will go through some examples, and I'll explain you the logic we are going to use to solve this problem, and then we will just go through the Java solution, right, the Java code. So let's start. So there is a one based binary matrix where 0 represents land and 1 represents water. You are given integers row and column representing number of rows and columns in the matrix, right? So they will give us how much rows and columns are there in the matrix. Initially on day 0 the entire matrix is land, right? Means everything will be 0 in the day 0. However, each day a new cell becomes flooded with water. You are given one based 2D cells array where cells of I is row and column location, right, which represents the ith day the cell will become like filled with water, right, for that row and column, correct? So that's given to us as an input. You want to find last day, that is possible to walk from top to the bottom by only walking on land cells. You can start from any cell on the top row, and you can end in any cell in the bottom row. You can only travel in 4 cardinal directions, right, like left, right, up and down, right? So return last day when you can possibly walk from top to bottom. So that's what the problem says. So they have given us couple of examples here. So for example, if you take a look at this first example, right, so they have given us input this thing like row and columns. So this is a 2 by 2 matrix they have given us, and in the beginning everything is filled with 0, right? You can see 0 means land, right? Now they have said that in the first day cell 1 will become flooded, right? So they have shown us here. So this is one best index, you can say, right? This is one best index. So 1 means this cell will get flooded, but we can cross it, right? Like from, they have shown us how we can cross it, one way to cross it, right, from top to bottom, right? So on the second day if you go, then the second cell will become uh, populated with water. So this is the cell, right, 1 so it became populated with water, but still we can cross from top to bottom. They have shown us in the red color right here. After that, on the third day, 1 2 cell will become populated. So now this cell, right, 1 2 is populated. So now there is no way we can cross from top to bottom, because the whole row, which is top row, is flooded with water. So we just cannot start walking basically, right, because everything is water. So we have to answer what is the last day we can cross. So this is the first day, this is the second day. So second day we can cross, right, third day we cannot cross. So we have to answer 2, correct? So this is what the problem is. So they have given us big example, so we'll just discuss using this big example here. So I just took the same example. So this is a 3 by 3 matrix that they have given us, right? Let me take the color. So 3 by 3 matrix they have given us, and these are the cells, right? So these are total 9 cells they have given us, right? So basically the positions for 9 days is given, right? Each day one cell will become populated with water or filled with water, right? So these are total 9 cells: 1 2 3 4 5 6 7 8 9, right? So total 9 days positions is given to us basically, right? So this one is total 9, correct? So this is 9 days. And if you just start looking into their pictorial representation, they are giving us the day by day positions, right? What will happen, right? So let's just first visually look at it, and then I'll explain you how we can solve this. So first day everything is land, right? So all zeros, so we can cross from anywhere. We can just crossing means we have to start from the first row and we have to reach end of the row. Basically any cell we can choose, right? Any cell. So this is now the first day, right? So first day, so I'll just remove these colors. So first day we are here, correct? 1 2. So they have shown us this is the cell which got filled with water. So still we can cross this, right? Either you can cross from here or here you can cross from here, right? So on the first day we are here, on the first day we can cross, we know that now, right? Now we are on the second day, correct? 2 comma 1. So now this cell will also get filled with water. So still we can cross as they have shown us in the red arrow, right? So second day also fine, we can cross it. Now let's take a look at third day. So third day means 3 comma 3 will get populated, right? So polluted with water. So this one got filled with water now. So total 3 cells are filled. Now as you can see they have shown us in the red color how we can walk, right? We can walk using 4 cardinal directions. So we can go left, up, down and right? So here they have shown us one way to walk this, right? This is the only way, by the way, we cannot use any other way. So third day also we can cross it basically, right? Now they have, now let's go to the fourth day. Second 2 comma 2 cell will get so this cell basically, right? 2 comma 2 means this cell, because they are using one best indexes, correct? So this will also got filled. Now there is no way we can cross, correct? If I start from here I'll get blocked here, right? If I start from here I'll get blocked here. We cannot start from this cell because this is already water here, right? So on fourth day we cannot walk basically, or we cannot cross from top to bottom, right? So the latest day is 3. So this is what we have to output as our answer, right? So this is what the problem statement is, and this is what the problem we are trying to solve, right? So we want to find out the last day, the latest day when we can cross, right? There might be couple of days where the crossing is possible, right? Like for example day 1, day 2 is also possible, but that's not the last day. The last day is 3. So that's what we wanted to return as our answer. So let me remove this color. So now let's discuss how we can solve this problem, right? So this problem basically can be solved with two very important concepts. One is binary search and other is BFS, right? Or breadth first search and binary search, right? So both concepts we are going to use to solve this problem. So why do we need binary search to solve this problem? I'll tell you that. So these are the 9 days that is given to us, right? These are all, if you count, we already know that these are total 9 days they have given, right? The position of the cells which are going to be filled with water each day. So total 9 days. So now how we will start, right? Means we cannot go from day 1 to day 9, right? Because that will be too much basically, right? If we want to check for each day one by one, right, then that will be too much and it will time out basically, right? Will get a TLE if we start going linear, right? So that's why we should choose binary search to solve this problem. So how we can use binary search? What we will do is, if there are 9 days basically, right, 9 days, so we will first find out the middle basically of this, right? So we'll start with the middle. So as you can see, I just put one stack trace here so that you will understand. This is a binary search stack trace, right? So 1 comma 9, right? So left is at 1 and right it as 9, right? So left is here and right is here basically. So we'll find out middle element, right? So middle element is 5, which means that we will check with day 5 basically, right? This is a day, right? So we will check if the crossing is possible on the number 5 day, right? 5th day. So we will check that, right? I'll explain you how we will check that, but you just understand first this binary search logic, right? So first we'll check it's possible on the middle, right? So we took the middle element and we are checking if crossing is possible. So now crossing is not possible on 5th day, we know that, let's say, right? So crossing is not possible on 5th day, then we will move the left half, right? So basically let me just write down. So this is basically we are here, right? 1 to 9, so we went here, so we checked this middle element, crossing is not possible, so which means that we have to now move our right boundary here, right? So we will only now check from 1 to 4 because anyway we cannot cross at 5, right? So we will check between 1 to 4 now. So again we will calculate the middle element of 1 to 4. The middle element of 1 to 4 is 2, right? As you can see, 1 to 4, the middle element is 2, correct? Again we will check on second day, right? We will check on second day if crossing is possible. So crossing is possible, yes, the crossing is possible on second day, correct? So this is 1, this is 2, right? So second day crossing is possible, and this is 3 and this is 4, right? So crossing is possible on second day. So now our we know that we can cross definitely at second day, which means that now we wanted to check from 3 to 4 now, right? 3 to 4 now we wanted to check, correct? Because 2 we already know that we can cross. Now we wanted to, our interval will become 3 to 4, days 3 and day 4, right? 3 and 4. So now again we are at 3 4, we will again calculate the middle of 3 4, which will become the day 3, and we will check if day 3 crossing is possible. Yes, day 3 crossing is possible, we just saw that, right? So day 3 crossing is possible. So whenever we find any crossing is possible, we will just update one variable, let's say the last crossing possible day, right? So whenever crossing is possible, we'll update it. So now at 3 crossing is possible, we'll update that to last possible day, right? And again we will now our boundary of the interval will again just go 4 comma 4 now. So left is also 4, right is also 4, so middle is 4, correct? We check middle 4. Once middle 4, we will find out if crossing is possible. No, it's not possible, so we will not update our last, so our last will be 3, correct? So this is the last day when the crossing from top to bottom is possible, so we'll just return that as our answer, correct? So this is the approach we are going to use to solve this problem. This is one of the hard problems on Leetcode and very interesting problem. So now we have seen how the binary search will work to solve this problem. Other thing now we wanted to check here is how we can use the breadth first search, right? Or breadth first traversal, correct? So let me just quickly do here the tutorial points. I'll just quickly open this. So this is the image, right? So let's see now how we can use the now the binary search logic we have already seen. Now we will see the logic how we can use the breadth first search, correct? So here we are here, right? Let me just make this big. So breadth first search means we will start at whenever we see any 0 here, right? Sorry, so we are at day 1. So first thing we have to do is whatever day we are checking using binary search, let's say for example here we are checking the 5th day, right? So we have to first find out the we have to create a grid how the cells will look on the 5th day, right? Because the cells will be populated, right? For example, here you can see if someone asks us how the cells will look on the 4th day, you can see here, right? So these 1 2 3 4 cells are populated, correct? So similarly we have to find out a matrix and create a grid basically that will tell us how the cells will look like on that day, correct? So we can use this input cells to create one grid, and we will create a grid, right? So that will tell us how the cells will look like on that fifth day. And then, for example, so let's just consider this example, right? So let's just assume that this is how the cells will look on the fifth day, correct? Fifth day. Let's just assume that, right? So what we will do once we create this matrix, correct, then we will go through the row, right? Whenever we see any zero, right, then we will start to do BFS, correct? We will use BFS or breadth first search or breadth first traversal, correct? Now here we cannot go to right, we cannot go to down, so we cannot go anywhere, right? So for example, right, then we will check this basically, right? Here we can go to down, so we'll try to go here again. We'll go in four directions. If we cannot go we cannot reach the end of the row, like the last row, then we will just return false, basically means crossing is not possible, correct? If we are doing a a BFS on this matrix, for example, then we will check here, we cannot go anywhere. Now here we will do BFS from this cell, correct? We have to start from the first row only, correct? So from here we will go here, from here we will go here, right? BFS in four directions. From here we will go here, correct? As soon as we hit the last row, right, we will just return true here, correct? True. So this is how the BFS will help us in understanding if we can cross from top to bottom, right? So BFS will help us in determining the possibility of crossing, correct? So we'll use the four directions, correct? Four directions: up, down, left, and right. So this is how our BFS part will work. So let me show you now so you must have understood the approach, the Java solution. Now we will discuss you will understand the Java solution with this approach, right? So first I just created this for the directions, right? Four directions. So this is our row and column which is given to us, cells is given to us, right? Row is 3, column is 3, and cells are this which is given to us, right? These are the cells, so that is given to us as an input. First I created one left, it is 1, and right, left and right variables I created, correct? Left and right variables. Right is at the cells dot length, correct? Because we want to do binary search, right? And days will be 0 in the beginning. Now using binary search, here now we started using binary search, right? Left is less than or equal to right. We will do this basically, right? We will calculate the middle day from this, correct? Left plus right minus left divided by 2. This will give us the middle day, and we have this one function we implemented, top to bottom walk possible, right? Here we will pass the cells, row, column, and middle day, basically. Mid means middle day, basically, right? And we will check if crossing is possible. If crossing is possible for that middle day, then in that case it means that we wanted to go to the right side, right? So there are two cases. When we know that we can cross for some day, the last crossing day would be in the right half, correct? So we wanted to check right half, so that's what we will do. If the crossing is not possible for that day, then which means that we have to go into the left half. So this is what we are doing here, right? This is the second case, right, where we are going left half. And then at the end we will know the days will capture the last day when we can do the top to bottom crossing, right? So now let's take a look at the top to bottom walk possible. So this is now BFS, right? So this approach is binary search. We saw this is the binary search, and this top to bottom walk possible is a BFS approach now. So how we will do the BFS? Let me just modify, make it big. So we first created one same size array as the cells, right? So this also has a row column. This is the same size grid as the cells. And what we are trying to do in this for loop is we are trying to simulate it how the grid will look like on that day, right? On the fifth day or on the third day, right? Or on the fourth day, how the grid will look like, right? Because already, let's say once we pass like 1 2 3 4, and when we are in the fifth day, already 5 cells are populated, correct, with water. So we have to simulate that basically, right? How the grid will look like on the fifth day or on that specific day. So that's what we are doing, right? So this is how we will populate that grid using the cells correct? So we will know now the grid will show like this, right? Like this. So it will show us how the grid will look like on that specific day. And now we have to do the BFS after that, right? Then we created a queue of integer array. It's just a linked list. Now what we will do is we first will go from 0 to number of columns, right? So we wanted to check if the first row has anything 0, correct? If anything 0 is there, that is our starting point for the BFS, correct? As I shown you here, right? So again I'll show you. So first row 0, right? First row 0. So these are our starting points where we can do the BFS, correct? So that's what we are capturing here, and we'll just add it to the queue, right? The 0 is a row and the column is C basically, correct? So these are the row and column for that specific cell, right? And we will change that grid to 1 so that we don't want to reprocess it, right? Once we add it, we don't want to reprocess it again, right? So we'll just change it to mark it as a 1, right? So now here our BFS actually starts, right? This is our BFS starts. So while queue is not empty, we are just going to poll the current, like we'll remove the from the queue the coordinate of the cell, and we'll get the new row and new column. Let's say we just called it as new row and new column, and we will check if did we reach the end of the row. If we reach the end of the row, then we will just return true, because it means that we can do the crossing from top to bottom, correct? If we did not reach the end of the row, then it means that we have to do the BFS, correct? For example, here we will do the BFS, here we will do the BFS, here we will do the BFS, because we did not reach the end of the row, and we have to do it in 4 possible directions, right? So we'll just capture the new X and Y using the this dir array that I created, right? It will give us the X and Y, means row and column, new row and new column for the BFS, right? Because we wanted to go in 4 directions, correct? 4 directions. So for example, if we are here, let's say, right? If we are, let's say, here, then we wanted to go up, down, left and right, right? So we wanted to check if these are all within the boundary of the matrix, and then if that should also be 0, right? Then only we wanted to consider it. So that's what, sorry, that should be sorry, yes, if it is 1, then we will just continue, right? Means we will not process it. It has to be 0, because it has to be a land cell, right? Then only we can walk basically. So here we are checking that we are within the boundary. If we are outside of the boundary or it is filled with water, then we don't want to process basically, right? Otherwise we will just mark it as 1 and we will offer that cell to the queue, correct? Because this is how the BFS works. So we'll keep doing it until the queue becomes empty, and at the end, if we reach here, it means that we cannot process, we cannot reach the last row, which means we cannot cross, so we will return false here, correct? So this is how the solution looks like. And here we always capture the last day when the crossing is possible, right? Days is equal to mid. It means that we are capturing the last day when the crossing is possible, correct? And at the end we will just return the days. So this is the binary search plus BFS approach to solve the problem, right? So if you are new to my channel, then on my channel there are you will find there are more than 200 different varieties of problems from Leetcode as well as Code Forces, Code Chef, at Coder, which are solved and explained using whiteboarding session examples and Java code. And those problems are taken from previously asked coding interview questions by big tech companies such as Google, Facebook, Apple, Amazon, Microsoft, Yahoo and many others financial companies. So if you are preparing for any Java J2E or coding interviews, then this channel can definitely help you. All the videos come with a whiteboarding session, just as we have seen here, so that you can understand the problems in an easier way. Those are explained with examples for your easier understanding, and always they come with the Java code. All this Java code you will find on my GitHub account. I'll give you the link in the description. You can check it out, the link. the code on the GitHub account. If you like my Java solutions, then please consider giving it a star on my GitHub project. That will be helpful. If you have any friends or colleagues who are preparing for interviews or simply want to learn Java concepts, share the videos with them. They can also learn from these videos and get help during their interview process. If you have any questions related to this problem or related to this video, please put your questions below the description section. Um, and let's just run our code now, and let's just make sure our code works with the examples that they have given us. So these are the examples that they have given us. So we are running all the examples to make sure our code works. So our code is getting accepted, as you can see, 2 1 and 3, 2 1 and 3. So all answers are correct. So we'll just go ahead and submit this solution now. So our solution got accepted by Leetcode. It is 41% fast on performance side and 39% on the memory side, which is pretty decent. So this is the way we can solve the last day, where you can still cross one of the hard problems on Leetcode 1970. So make sure you practice these problems, you understand the logic and how we solve the problem. Whenever you are implementing the Java code, like make sure not to use the IDE, because many times in the interviews you have to just handwrite the code. So try to remember, as much as you can. That will be helpful to you. And thanks for watching this video.